Hello and welcome to today's webinar, Empowering Data-Intensive Applications with Pure Storage FlashBlade for AWS Outposts. This event is presented to you in partnership with Pure Storage, Amazon Web Services, and NVIDIA. Thank you so much for joining us on this webinar. We've got a really cool presentation lined up for you today. Before we jump into it, just a few things you should know about the event. My name is David Davis of Actual Tech Media, and I'll serve as your moderator. We want this to be an educational event, and as such, we encourage you to use the questions box in your audience console. We'll be doing a dedicated Q&A session at the end of the event, and also we'll be answering questions throughout the webinar, so get your questions in early. We have a number of handouts available for download in your audience console, so I encourage you to check those out. We'll also be announcing the winner of our Amazon $300 gift card at the end of the webinar. If you're watching this on demand, I'm sorry, the drawing has already occurred. The prize terms and conditions can be found in the Handouts tab. And with that, I'm excited to introduce you to today's expert presenters. They are Miroslav Klavansky, Field Solutions Architect at Pure Storage, Brad Hedlund, Senior AWS Outposts Partner Solutions Architect at AWS, and Mr. Dave Salvatore, Senior Product Marketing Manager at NVIDIA. Miroslav, Brad, and Dave, so great to have you on the event today. Before we jump into our discussion, I want to first talk for a moment about today's topic. Why FlashBlade and AWS Outposts? Many of you are still learning about AWS Outposts, and what you'll learn today is that by combining Outposts, Pure Storage, and NVIDIA technology, you can do even more. The reasons that more companies are looking at AWS Outposts are to enable modern analytics. Companies need business intelligence and they need to make decisions fast. But more and more, that requires a tremendous amount of data and analysis. AWS Outposts brings that capability on premises. Outposts also enables artificial intelligence, and with AI, the possibilities are endless. And finally, when combined with FlashBlade Rapid Restore, you can rapidly recover an incredible amount of data. And again, this is a capability that more and more companies require. Now, specifically into FlashBlade and AWS Outposts, this partnership provides high-speed data availability for analytics and AI workflows. You'll have the ability to store billions of files and objects, and Rapid Restore gives you the capability for backup, disaster recovery, and ransomware mitigation. And finally, FlashBlade and AWS Outposts provide you the management of significant amounts of user and machine-generated data. On today's webinar, you'll learn about the incredible power of combining AWS Outposts, Pure FlashBlade, and NVIDIA technology. So with that, let's get started. I'll now hand it off to our first presenter from Pure Storage. Take it away, Miroslav.
Thanks, Dave. I'd like to share how AWS Outposts, NVIDIA, and Pure Storage can help you deploy some of the most data-intensive applications. Today, we'll be exploring how you can empower some of your most data-intensive machine learning applications. So, machine learning and deep learning have rapidly become powerful tools for gaining actionable insights from data. And AWS made it easy to build and refine accurate ML models, letting everybody get started quickly with access to the world-class NVIDIA hardware. But machine learning in the cloud has some important limitations, especially when it comes to applications with low latency or bulk data requirements. That's why AWS, NVIDIA, and Pure Storage have partnered to deliver an integrated solution for ML at the edge. With AWS Outposts, NVIDIA-powered G4 instances, and Pure Storage FlashBlade. The combination can run in private and edge data centers handling ML applications that need low latency, or to process large data workflows without uploading them to the cloud. We'll dive into the why and how of it during this talk. And to start off, let's consider what it takes to deploy machine learning at scale. When you survey the trade press, you'll see what defines AI, and you'll likely see three types of information. First, it's all the new and amazing capabilities that AI can bring to bear on a range of problems. Second, the various frameworks available to implement these solutions. Lastly, cutting-edge hardware for those frameworks that's rapidly improving while Moore's law slows down. But AI is so much more. If you're a data architect or engineer responsible for industrial-scale AI, you know this very well. Google published a paper 5 years ago exploring the pitfalls when going from quick wins to deploying for real-world workloads. The ML code is just a small fraction of real-world machine learning operations. Much of the system is dedicated to data collection, cleaning, labeling, verification, and management, as well as the infrastructure. In their words, the required surrounding infrastructure is vast and complex, and it's dangerous to think that these quick wins as coming for free. Using the framework of technical debt, we find it's common to incur massive ongoing maintenance costs in real-world ML systems. So, many teams have hired bright data scientists, invested in infrastructure, but still can't find the ROI from AI. It's summed up nicely in this tweet. The story of enterprise machine learning. It took me 3 weeks to develop the model. It's been more than 11 months and it's still not deployed. Many organizations will find the expression model debt very familiar. Shortcuts on the path of developing a model may make it challenging to deploy it at scale. How much investment goes into undeployed models or deployments that need to be rebuilt to keep up with demand? There are a number of reasons for that, and we're going to dig into some of those root causes. Consider a classic example around medical imaging like in the bottom half of this screen. You've got your primary data sets and process them for the model you're building. Once you've got a model you like, you train it on the bulk of the data you collected and validate the final accuracy. Now you'll be able to run inference and identify interesting features in the images. And if you're a data scientist who did that on your workstation, huzzah, you've got your model and you're done. But if you wanted to scale it into production, it's going to have a bunch of ancillary workloads. There's a good chance you've got a Kubernetes environment you're planning to use for inference at scale. You likely have some message queues like Kafka for data ingest and to coordinate between different components. Maybe there are many data scientists, analysts, and architects who use IDEs like Jupyter Notebook to develop and share code. You need to save all those custom container images somewhere. You might have some structured data like patient or financial records that you use to enrich your models or output. All of this complex infrastructure needs logging, monitoring, and reporting. These additional components need to be looked at comprehensively. It makes sense to step back and say, how can we simplify this? How can we make this whole set of disparate workloads as easy to manage and to scale as possible? So on the storage side, data sharing is greatly improved by using the same centralized storage underneath all of the applications in this platform. Pure's FlashBlade is great at handling all the different I/O patterns and is accessed via both NFS and S3. That means it's well suited for hosting any of the components that we've talked about. Now, let's consider ML and the cloud. New machine learning projects often start in AWS. It's simple to get started without lots of red tape, and there's little upfront investment. Plus, AWS is very familiar to data scientists from their training and many available references. That makes it the go-to resource for teams who have ideas and need to show the potential to get buy-in from their organizations. AWS also offers many powerful tools for automating and supporting ML workflows, and instances with powerful NVIDIA hardware for training and inference. Lastly, the entire AI field is moving to and evolving towards ML ops. These build on cloud-native DevOps traditions. AWS is already optimized for DevOps, so doing ML ops there builds and adapts the DevOps approach. But there are situations where cloud-only approach to ML isn't enough. In particular, two types of applications need extra support. Applications that require nearly instantaneous responses can't wait the extra milliseconds of round-trip time to the cloud. These include applications like manufacturing systems, where the application controls the machinery and uses ML to recognize defects or sort inputs, conversational AI interacting with customers, or recommendation engines that are an important part of frictionless user experience. The other category is for applications that need fast responses and process large volumes of data that doesn't make sense to retain in the cloud. If the data becomes stale during upload, or most of it is discarded after processing, it makes more sense to process it at the edge. Applications that annotate broadcast data or do real-time anomaly detection with video and other sensor data fit into that bucket. That's where the hybrid cloud model and AWS Outposts play an important role. They extend the cloud benefits to more applications and allow applications to run where they're most efficient. AWS Outposts and FlashBlade are a powerful combination for extending ML from cloud to hybrid. So let me hand things over to Brad to tell us more about Outposts.
Thank you, Miroslav. My name's Brad. I'm going to give you a quick overview on AWS Outposts. AWS has the largest global infrastructure footprint with 24 regions around the world, and this footprint is constantly increasing at a significant rate. So with all of these regions available to run workloads, why is that not good enough for some customers? Why do they want a service like Outposts? Well, customers have told us that some of their business critical applications are sensitive to latency and variability in latency. They need these applications to run on premises to respond to events with extremely low latency. They cannot afford the round trip to the cloud and back for these applications to run efficiently. Customers have also told us that there has been an exponential increase in data kept on premises. They have data intensive workloads that collect and process hundreds of terabytes a day. Transmitting all of this data to the nearest AWS region is time consuming and it's expensive. And also some customers are under regulatory controls. That require them to keep their data in the country or within the four walls of the building. AWS Outposts is delivered to customers' location in the form of an industry standard 42U rack of equipment like you see in the picture here. This is a real outpost ready to be delivered to a customer. Customers can start with a one rack and grow their outpost with additional racks when and as needed. We support 16 racks today, and even more will be supported in the future. The theoretical limit of a single outpost is thousands of racks. The rack arrives fully assembled, ready to be powered on. All of the cabling is connected, labeled, and organized as you see here in the picture. The outpost rack is built to be resilient. It has redundant active components such as redundant power buses and redundant network switches. And to connect to the on-premise network, the Outpost has two network switches that support 10, 40, or 100 gigabit Ethernet connections. And then from the on-premise network, the customer just needs a 1 gig connection to the AWS region using Direct Connect or VPN or just the plain internet. This is so that the Outpost can establish its service link to the AWS region. The Outpost is installed by AWS. The customer just needs to provide a site address for where they want their Outpost to be delivered to. And on installation day, the Outpost will be rolled off the truck and into the customer's data center and connected to power and the on-premise network. The hardware in the Outpost rack is the same hardware AWS uses for racks in the regions. However, an instance performs in the region is how it will perform on Outpost, giving the customer a seamless experience between the cloud and their on-premises. Furthermore, AWS Outposts is a fully managed service. AWS is responsible for the day one installation and the day two monitoring, maintenance, patching, and security of the hardware and software that makes an Outpost operate. AWS is managing the Outpost rack the same way it manages any other rack in a region data center. Leaving Outposts is really a seamless extension of an AWS region. Customers can see and manage all of their resources in the AWS region and on their Outpost from the same AWS console they are using today. So what can a customer do with their Outpost? Well, customers can run AWS services on their Outpost, but not all of them. You can see on this slide the AWS services they can run on their Outpost today and some of the limits of those services. For EC2, customers can run EC2 instances on their Outpost, but only the newer Nitro-based instances such as the M5, C5, R5, i3, and the G4, which we'll be talking about today. They can also run the AWS container services on their Outpost like EKS and ECS. They can run EMR clusters, and they can also launch and run RDS databases locally using the MySQL and Postgres database engines. And these database engines are single AZ only. The multi-AZ feature of RDS is not available on Outpost. Customers can also run S3 locally on their Outposts. They can create S3 buckets that live on their Outpost with a maximum of 96 terabytes of storage for their S3 buckets on the entire Outpost, whether the Outpost is one rack or many racks. They can also populate their Outpost rack with up to 55 terabytes of storage for EBS volumes that will be used for EC2 instances. And those EBS volumes can be GP2 only. The Outpost does not support any other EBS volume type. There are no native file-based storage services on Outpost. So if a customer needs file-based storage, they're going to have to find a storage partner to help them with that, like Pure Storage, or build it themselves. Also, the maximum power draw for an Outpost rack is 15 kVA. And as a customer adds storage to their Outpost, the hardware needed to power that storage will draw from that 15 kVA power budget. That's why personally, I'm a big believer in using external storage for AWS Outposts wherever and whenever possible, especially when you want your Outposts filled with as many EC2 instances as possible. To do that, you would populate your Outposts with just enough storage for the EBS volumes you need to boot and run your EC2 instances. And when you need to access a large local data set, have your EC2 instances connect to an external storage array like Pure FlashBlade and save your Outpost power budget for more EC2 instances. But before you do all of that, you'll want to make sure that the storage partner you're working with has a lot of experience with Outpost, that they have tested it before and they know it works and it performs well, and that they will support you. That's why AWS created the AWS Outpost Service Ready program. We wanted to de-risk the customer's decision to use a partner solution by giving recognition to those partners that have tested and proven that their solution works with Outpost, that they know how to use and deploy their solution on Outpost, and they can support their customers that have Outposts. I'm delighted to tell you that Pure Storage is one of the first storage partners to earn the Outpost Service Ready designation for their Pure FlashBlade. And here's the lab testing diagram that was used in this lab. It was in this lab you see here where Pure Storage spent many hours testing and validating the use of Pure FlashBlade with AWS Outposts. They tested performance, high availability, and they also wrote thorough documentation on how to set the solution up. So without further ado, I'll pass the next section over to our next presenter, Dave.
Okay, thanks, Brad. So as we talk about AI and how it's changing industries and how AI is just bringing change to so many different types of usages, it's important to understand what's driving this. Since we've gotten started with accelerated computing, accelerated AI in particular, we've seen just an explosion in the growth of the size of neural networks. If you even go back just a couple of years to ResNet 50, a popular image-based network, we've seen a growth factor of about 30,000x, even in just the last 4 years, if you look at some of the current cutting edge language networks like GPT-3, for instance. So that growth is something where developers are taking advantage of the new performance they have, but they continue to drive the need for more performance as they want to expand networks, work with larger data sets, and bring those results back to people in real time to power AI services. And in terms of what some of those services are, if you look at the right-hand side of this slide, you begin to get a sense of just sort of the scale of things. Billions of content recommendations, thousands of ads served up per day per person, medical scans numbering in the millions, and of course, hundreds of millions of conversational AI interactions, whether that's from AI assistants, support bots, and the like. So the usages are currently really driving the networks, which in turn drive the need for accelerated computing. So inference is sort of the second big operation in AI, which happens after you've gotten a network trained and you're ready to deploy it, you're going to be doing inference. But inference in and of itself can be pretty complex to get going. You've got to bring in huge data sets. You've basically got to get them optimized. Sometimes you need to even, sometimes you'll build a network from the ground up. Sometimes you'll be able to take an existing network and train it with your own data, right? And then from there, you want to optimize that network and get it ready for inference so you can inference in the most efficient way possible to minimize compute resources and minimize cost. And lastly, of course, you want to deploy it in a way that's both easy and yet flexible, and of course, scalable. And that's where you want to be able to, load balance on the fly, for instance, if one particular service is generating a lot of demand. So in order to meet all these requirements, we have a number of tools that help you do that. We have what's called our Transfer Learning Toolkit, which helps you use existing trained networks where you can apply your own data set. TensorRT, which allows you to then optimize these networks and get them ready for deployment to use things like reduced precision, layer fusion, and a number of other features. And then last, we have our Triton Inference Server software, which supports multiple frameworks, allows you to do auto load balancing using Kubernetes, and allows you to sort of maintain that optimal amount of utilization across GPUs and CPUs and make sure that no one of them gets oversubscribed, so that if there's a sudden spike in demand, you can automagically essentially redistribute that work across available GPU compute resources. So all of these things are part of our overall NVIDIA AI platform, right? And it starts with data analytics and training, which is sort of, you can think of that as sort of the front end of the pipeline of the deep learning overall operation. We then get into inference. And again, as I touched on just a minute ago, whether that's pre-trained state-of-the-art models, using our Triton Inference Serving software, the transfer learning toolkit to take advantage of pre-trained models, and of course, TensorRT to optimize those models and get them ready for deployment. We also then have application frameworks which span multiple industries and usages, and I'll touch more on those in just a few minutes. Another important resource as part of our platform is what we call NGC. This is a container repository where most of the software we make, in fact, nearly all the software we make, is available for free. And this includes containerized, optimized versions of software for AI frameworks, for TensorRT, for Triton Inference Server. It includes pre-trained models, industry application frameworks, Helm charts, and even now collections, which are entire workflows, which we have containerized and optimized to make them easier to deploy. These, of course, are available across multiple platforms, and this is very relevant to today's topic about deploying them either in the cloud, on-prem, or hybrid, or at the edge. So this gives you another degree of freedom to be able to work faster, to get your services deployed in a way that gets you with live services that are generating return on investment quicker. So at the foundation of our platform are our data center GPUs. Today's focus is really more on the NVIDIA T4, which is really a great solution for inference. It's also good for things like virtualized graphics and for even mid-range workstation virtualized graphics. It features 16 gigs of GDDR6 memory, and it of course has Turing Tensor Cores, which is our second generation of Tensor Core technology. It's a great solution. It's available in the G4 instance, which I'll cover in just a moment. And then other members of the family include the NVIDIA A40, which we recently launched. And then another one, which I want to spend a minute on, of course, is our NVIDIA A100, which is now available from AWS via the P4D instance. This is our most powerful data center GPU, a phenomenal solution for training. It also offers FP64 precision for those interested in HPC workloads. It can be virtualized. It also offers our NVLink and NVSwitch technologies to allow for faster GPU communication, and is overall really kind of the powerhouse member of the family. So particularly for training, NVIDIA A100 is really the ideal solution. NVIDIA T4, which can do what we call sort of small scale training, is also a very versatile part and is really best suited for inference. So sort of taking that into the cloud, we have, basically our NVIDIA T4, as we've just talked about, a great multi-purpose GPU that covers a lot of ground. It also offers up entry-level workstation graphics, as I talked about just a minute ago. And then that finds its way into the AWS EC2 G4 instance, which can bring dramatic performance boosts, can help reduce cost, can also help dramatically reduce time to solution. So when you think about the time is money piece of developing these workloads, that becomes super important. And we'll talk a little bit more about that as we move through the slides. And of course, as previously mentioned, it also offers high performance graphics. And then all of that comes together in AWS Outpost, which allows for low latency compute, keeping your data local on-prem, and again, data residency related to that. Your data can live sort of in your data center. And it allows for much easier migration and modernization in terms of migrating workloads to and from the cloud. So when you put the NVIDIA T4 solution together with G4, together with Outpost, what you get is an incredibly flexible solution that gives you great GPU acceleration, both on-prem, in the cloud, and for hybrid implementations. Now I want to talk a minute about use cases. We talked about this earlier, but I want to spend a little bit more time. One of the important things about use cases that it's really key to understanding is that many of them are now using more than one neural network. In fact, some can be using more than a dozen neural networks to deliver a single answer. So if you think about that in the context of a real-time service, what that means is you've got to get through your inferencing operations on 10 plus neural networks in under a second. And that really, again, underscores the need for accelerated inference computing. A lot of inference computing historically was maybe done on CPUs in large batches overnight, which wasn't a bad model. But as the world increasingly looks for these real-time services, making use of multiple networks, what we sometimes call an ensemble of networks, what you see is that the need for accelerated inference goes from being a nice to have to being a must have. So talking a little bit more about that, conversational AI is one that we've been focused a lot on here at NVIDIA. And it really shows up in a lot of different usages, whether that's video conferencing, which is something we're obviously all doing a lot more of these days, call centers, which we also reach out to all the time, smart speakers, which many of us have in our homes, retail assistants, which are increasingly now important on websites for e-commerce, which is how we're doing a lot more of our shopping these days. And then, of course, over time, we're developing ever smarter in-car assistants. So again, conversational AI is going to be showing up. It's already showed up in a lot of places and will continue to show up in even more. And in a similar way, recommendation engines are a hugely important part of the internet. In some ways, recommendation is the new search. And when you think about that in the context of just how many recommendations are happening every day, and we've just got a few numbers here to help illustrate the point, you can see that the numbers quickly scale into the billions. So as you look to build more intelligent systems, and by the way, sometimes those conversational systems and those recommendation systems are all working together. And so what happens there is, again, you have this ensemble of networks that you have to get your inferencing done on in under a second to return that answer back to somebody waiting for their answer. And so I also want to then talk briefly about some other industry-specific platforms that we offer, whether that's robotics in terms of our Isaac platform for doing things like simulation, whether that is for smart cities and video analytics with our Metropolis platform, autonomous vehicles, we offer our Drive platform. We're doing a huge amount of work in the healthcare industry, both for medical imaging as well as for things like drug discovery, which is obviously taking on a much more critical importance given the current pandemic we're living through. Manufacturing with our Jetson platform, and finally 3D rendering with our Omniverse collaborative platform. So the basic takeaway here is that when you combine the power of the NVIDIA T4 GPU, along with the NVIDIA AI platform, along with the G4 instance, and put that all into an Outpost solution, what you get is a really versatile solution for cloud, on-prem, and hybrid, and all the software you need to get your solutions deployed and speed return on investment. And so now I'm going to hand it back over to Miroslav to talk to you about pure FlashBlades and how they can help accelerate all these usages on Outpost.
Thanks, Dave. Now, let me go into a little bit more depth here about Pure Storage FlashBlade and AWS Outposts. Well, first, let's talk a little bit about the modern data experience. The modern data experience delivers data services that enable next-generation applications and support new business models, giving your organization an edge. Pure believes that for our customers, there are 4 principles that will deliver on that promise of digital transformation. Fast matters, cloud everywhere, simple is smart, and having a subscription to innovation. These principles are the foundation that allow our customers to accelerate their core applications, deliver real-time analytics and insights from ML pipelines, enable data management and security with hybrid cloud, and modernize data protection. What are some of the other use cases that FlashBlade and Outposts help address? Well, first is rapid restore, because it's not about backing up data, it's about getting it back quickly when needed. FlashBlade lets you reduce downtime by rapidly recovering your hosts and instances, plus keeping them safe from ransomware. Next, FlashBlade offers a high-performance and highly scalable storage system. We deliver higher throughput, lower latency, and much greater capacity than what's possible natively with Outposts S3 and EBS. And if you need additional instance storage, FlashBlade NFS is right there on the same system. Lastly, FlashBlade lets you address data sovereignty, compliance, and security requirements. All the data on your FlashBlade belongs to you and resides in your secure data center. Plus, it's always natively encrypted at rest with rotating keys. So the benefits of FlashBlade with AWS Outposts goes further than unlocking low latency and local data applications. FlashBlade is designed to be a data hub for sharing data among many applications and environments. That makes it an ideal connection point for multi-cloud and hybrid deployments. Use FlashBlade to host and access data from other applications running on your hardware in the same data center. Have other instances in the AWS region access FlashBlade with low latency. Pull in data from multiple cloud environments onto the same FlashBlade platform. Plus, provide better storage performance and flexibility for hyperconverged platforms in the data center. Another aspect of FlashBlade that fits well with AWS Outposts is our OpEx consumption model. Pure as a Service is designed to provide the same purchase experience customers expect from the cloud. Customers enjoy the economic benefits, but Pure as a Service is more than just a consumption model. The operational value provided by Pure as a Service is a key differentiator compared to competitive offerings. Now, let's get a bit more technical again and go back to MLOps. There are multiple stages in the MLOps workflow, and each often has different requirements on storage. Today, each stage is frequently built in different physical silos, and that's where a fair amount of the delay and friction comes from. Architecting the workflow that way forces the data to be transformed, then copied from one stage to the next. When we talk to customers, they estimate wasting about 20% of their time waiting for data to move from one silo to the next. The reason they're doing it is to address two common challenges. Challenge 1. Data is often stuck in complex infrastructures and sprawling silos. And guess what? Storage industry is largely to blame. Our industry offers customers numerous data silos, data warehouse appliances, data lakes, streaming analytics clusters, and now AI clusters. And if you're running infrastructure as code, all that code, the development platform, and the artifacts used in development and operation need persistent storage too. Same goes for developing AI models, dashboards, or reports on Jupyter notebooks. Each silo is useful for its original task, but in today's data-first world, silos are counterproductive. Data in software dev is out of reach from AI clusters. Data in data warehouse is out of reach for streaming analytics workloads. You need orders of magnitude more data for incremental improvements in model accuracy, but that data is trapped in different silos. Plus, all these silos are individually growing, which is adding unnecessary complexity to the infrastructure. Challenge 2. All of the different applications and stages in the pipeline have different workload and storage needs. Ingesting data requires high throughput sequential writes. ETL can have all sorts of access patterns. Exploring data to find patterns and build models can be very random and often requires low latency for interactivity. Training is very parallel and requires high throughput random reads to many small objects. And production deployments do inference on all sorts of sequential data streams and tend to be randomly accessed to different forms of enriching information. That's why the different applications and stages ended up siloed. It was the easiest way to address the needs for each application and stage. But now there's a better way to do it, unifying fast file and object workloads on FlashBlade to enable data sharing and handle the full range of storage needs in one place. FlashBlade is truly dynamic, architected for the unknown in big data. Here are 6 things we believe are essential for AI and modern analytics that FlashBlade delivers. It's tuned for everything, from small to large files, random to sequential access, structured to unstructured. It's optimized for any workload. It's real time. Think self-driving cars or voice assistants. If response isn't in milliseconds, then the applications become useless. It's all flash. From software to hardware, FlashBlade is optimized for flash. It delivers the performance, density, and power efficiency needed for modern solutions. It's massively parallel. ML and analytics are massively parallel. GPUs have thousands of cores. In the same way, FlashBlade is built from the ground up to be parallel. It's elastic. Modern infrastructures need to spin up and down instantly. FlashBlade delivers more performance and capacity in minutes, simply by plugging in more blades. And it separates compute from storage, enabling simpler, independent scaling. Lastly, it's simple. There's no manual tuning and retuning for a specific application. And with our evergreen business model, you can incrementally increase capacity and performance, pay only what you add, and never rebuy storage. All of these together make it possible to unify all the stages and applications in the MLOps workflow onto a single FlashBlade, eliminating those copy and transform operations. So let me hand it back to you, Dave, to help us wrap up.
Fascinating content all around. Thank you to our expert presenters. It's so exciting what you're doing together with AWS Outposts. Before I announce the winner of our gift card prize, I want to encourage everyone to visit purestorage.com/AWS reInvent to attend the AWS reInvent 2020 conference, no travel required, and learn more about AWS Outposts, Pure Storage, and NVIDIA technology. Visit purestorage.com/AWS reInvent to register and get more information.